Итак, все-таки начинаем нашу лекцию, хоть и с некоторым опозданием. Hello, students. On our last practice lesson, I noticed that some of you have problems with English language. They even cannot ask Google some simple technical question. This is not very good. English language knowledge is necessary for every IT specialist. Whatever sphere of IT he is participating into. Several days ago, I was on free webinar of professional English language trainer, and she has convinced me that the only effective way to learn foreign language is to have a lot of speaking and listening practice. Human's brain is constructed so that even if you have a large dictionary of foreign words, but you do not train to use them, you won't be able to speak. So I decided to read this lecture in English. My English is very bad. I have strong Russian emphasis. My dictionary contains only a few hundred words, so I don't think you will have problems understanding me. You understand me now? You may speak Russian.
It's not so interesting.
It's not interesting, but it's practice. It's necessary practice. When you grow up, when you take your diplomas, when you finished 1 or 2 years of your first work, you will go somewhere else, to Google, to Microsoft, to Apple, to Valve, and here you will need to know English.
To cleaning company.
And if this will be foreign cleaning company,
Okay.
so
I love Russian hotels and I will work here. In our cleaning company.
you may have foreign clients, you may have outsourced programmers in India. This is not great, but this is reality. They speak English. Their English is even worse than mine. So the first thing I would like to talk about on our lecture are configuration files of network stack in Linux. You already know several commands to configure network stack. Ifconfig, route, IP, netstat, but all these commands are just configuring network stack of running kernel, and after reboot all settings will be lost. To not lose settings, you may store them in configuration files. So the first important configuration files are files that determine network devices naming. For example, you have a USB Wi-Fi adapter. You plug it into first USB port of your computer, configure it, then you plug it in the second port next time, and it becomes not ETH0, ETH0, but ETH1. So all your settings are lost. To prevent this, in modern Linux distros, the UDF package is used. UDF is package that handles device naming and hot plug events. It is not only for naming network interfaces. You may, for example, configure some actions on your flashcard insertion. So, etc odf rulers d. Here we see file persistent net rulers. This host has 3 network interfaces, and you see that for each of them name ETH0, ETH0, ETH1, ETH2 is configured corresponding to its MAC address. So if you insert plug USB network card in your computer second time in different port, it will appear with the same name. This is convenient. This is also convenient, for example, in big serious server. You have 2 PCI network interfaces. You plug in 2 more PCI network interfaces, and the old interfaces do not lose names. ETH0 doesn't become ETH4. So your configuration is not lost. For strange distribs without UDF support, you may use package if rename. Its configuration file is called etc iftab. I don't know its syntax. I haven't ever used it, but you can see it in manual page. So with these config files, now we have network interface names persistent. Now we want to configure these interfaces. In Debian-based distribs, all configuration is done in etc network. In Red Hat-based configuration files reside in etc sysconfig networking. We have Debian-based distro here, so let's network. The main configuration file is interfaces file. So for every interface that we need, it contains its address, net mask. It may also contain gateway, you may see man interfaces. It's rather long. And for interfaces, here you see directories if down D, if post down D. So scripts in these directories are run when interface is configured up or when it is going down. For example, in if up D, you may see files, for example, by bind DNS server packet. It reconfigures DNS server every name when some interface is added or is configured, so that it always listens on all IP addresses. For example, mount NFS script for mounting network file systems such as NFS or SMB, Samba for Windows networks. And in interfaces file, you may write something like pre-up pos to script, and then this script will be executed before interface eth0 is going up. Any questions?
I have a question about you said that each ETH 0, 2, and 1 are arranged by MAC addresses.
Yes.
But what will happen if we will insert new device which has less MAC address? We insert this device and then devices which we inserted before.
Okay. Так, etc udef. In this file you see that interface with MAC address 08 26 will always have name eth0, the first line. So when we insert some other interfaces, it will get some name like eth3, eth4, and its name and MAC address will appear in this file.
And next time the record of ETH, for example, 3 will be saved.
Yes.
And next time
Yes, next time we plug in the same interface, it will become eth3. Any questions on interfaces file? It's rather simple. After line means that we should bring interface up on system boot. And other lines are obvious. Address, mask. Okay. And now name resolving. Running Unix system has necessity in resolving name of network hosts, of networks, of named protocols, of users, of mail aliases, and all these name services can be configured fluently. File etc and a switch conf. So look, for hosts line, to resolve host name, we first look static files. Static file is etc hosts in Windows. Question? Email aliases, for example, your main name is root at your system.your domain, but you also want to have mail. You also want to see mail to webmaster at your host.your domain. Then you can make webmaster at your host.your domain alias for root, and mail for webmaster will come to root account. So here this is a hosts file. You may see host file in Windows only. It's located in Windows directory system32 drivers etc hosts. Directory etc appeared there because network stack for Windows was ported from BSD family of Unix systems. It have permissive license, so Microsoft could legally make this. Here this is a host file with statically configured host names. Localhost and our host name. And in etc resolve conf we see configuration for DNS servers. Host C is DNS server itself, So we see here loopback address, for example, host A. Host A isn't DNS server, so we see here name server address, address of host C, and domain and search. So domain is default search domain for resolving short host names. For example, when we run nslookup host C, it resolves hostc.net 188.9.lan because this is default domain name. And if we didn't found this host in net 189.lan, then it resolver will try to search some other domains that are listed with search entries. We may have many search entries here. For example, if host didn't found short name in first domain, then it will look in second domain and third and so on. So files for resolving host names are etc hosts static entries and etc resolve conf for DNS servers. But you should remember that all this is configured in ns-switch-conf. If you remove files word from hosts line, then hosts file will not be, then system will not look into hosts file. If you remove DNS word, the system will not try to resolve host name by DNS server. Okay, here, first file etc hosts static entries. Second files etc resolve conf for DNS servers. But here in hosts line, this is configured that hosts files DNS. First we look the static file, and second we look DNS. If you remove some of these words, if you remove word DNS, the system won't look at the DNS servers even if they are presented in resolve conf. On other systems, for example on Ubuntu, in this file in hosts line you will see mDNS, multicast DNS. It is used for hello.
Что ты палишь меня?
You may see in host line mDNS entry that is used for zeroconf. I didn't ever see running and working zeroconf. I cannot talk you much about it. It is standard that allows devices to work together, not being configured at all. It's for small home networks.
Можете повторить еще раз, что будет, если DNS убрать слова?
If you remove DNS word, if only files word will remain, then to resolve host name, system will look only in hosts file, only in file with static host name entries. It will not try to resolve host name with DNS server that is configured in resolve conf. Okay.
So in this case, the system for the first time will see files
Yes, and if it didn't find anything in files, it will look DNS. If we change this word, then the first host name will be searched in DNS, and then it will be searched in hosts file. You may see syntaxes in manual. Any questions? No questions. Does somebody understand anything? This is great. Okay, you know names of and syntax of utilities to configure a network running network stack. Now you know files to configure a network stack with persistent configuration that will be restored on every reboot. So let's go to firewall. Let's go to Iptables. Actually, Iptables works so very simple, as you see. But in practice, for most cases, you will need only this picture. It's not so complicated, and for most cases, it's enough. Yes, if such a simple picture helps you to configure a firewall, this is great. So, firewall in Linux kernel since 2.4 version is called netfilter. Iptables is just utility to configure this firewall. But firewall is often called Iptables. Okay. Generally, there are two kinds of firewalls, stateful and stateless. Stateful firewall can see if a packet passing through it is да. Печаль. Как я уже упоминал, английский мой не так хорош, как хотелось бы. That packet passing through it is corresponding to one of existing connections. For example, if the TCP connection is established, so from our host to some remote host, then our host sends the first packet and the remote host sends some packet to answer our host. Stateful firewall can see that second packet is for our new established connection, is related to it. And stateless firewall cannot see this. So stateful firewalls are much more powerful, but this causes problems with performance, because in stateless firewall we don't need to keep track of all the network connection, we just check every single packet and forget it. So Iptables is stateful firewall. The abbreviative SPI, stateful packet inspection. I don't know word перемена in English. Pause.
Coffee break.
Are everybody here? Okay, close the door. Close, close. Our today lecture is read in English.
И все вопросы надо по-английски задавать, понял?
It's not a hindrance for me.
Вот так вот, ну ладно, блин.
Ну там Сименса научили.
Yes. And
Латышский баллад.
at the beginning of our lecture, I forgot to check out
Мне вот интересно,
which students are here.
Там везде моя фотография будет вместо тебя кого-нибудь.
Дениса меня.
Ну да, че, Гоша? Средний ряд,
So,
короче, есть.
can I see Mr. Bahayev?
Фотки поставь. Не рисуй.
Okay.
Это все. Не, подлиннее надо.
Here he is. Okay.
Как-то
Так. Okay.
быстро пошло.
Can I see?
Нету ее.
Поставьте грустно.
Так. You're only on the second lecture.
Second part of lecture.
Second part of lecture. Are you working or are you sleeping? What a good work!
Тут нужно, короче,
He's sleeping for money. I want such work.
Dream job.
Так.
Красиво он у вас. А что, лохно не будем рисовать? Там нужно двоеточие такое, это, слэшик. А, или тильдочку.
Подумал процентную выборку.
Так. Так.
Эмиль, Саша, я уже.
Так. Есть.
Здесь. О, хорош.
Так.
Почему со средней-то вырезали обязательно? Нет, это не средняя, нет?
Это средняя,
Это
средняя.
да.
Так. I don't see Наталья.
Да вы удаляйте тех, у кого нету. Человек черный. Удачный кадры.
I'm here. I'm white and can go.
Не удалось. Понятно. Вот у меня 23 февраля взяли.
No, he's here. Okay.
He's absent.
Тот парень, который поставил фотографии, как-то...
From ВКонтакте.
Так. Here. Here. Okay. Okay. And now about Iptables. Iptables are very simple. Packets are passed through chains of rules. And each rule chain цепь. Each chain has list of criteria. Each rule has has some criteria, and if packet match criteria, we apply some action to it. We may reject it, we may pass it, we may take the packet to another chain, and every rule has counter of packets passed through it. So we can use Iptables for traffic counting. Here you can see standard chains, pre-routing, forward, post-routing, output, input. But user may create his own chains. User chains are used like functions. If you have some complex functionality you want to apply to some packet, you may take it into user-defined chain. So the rules will become more clear, and this can increase performance. Yes, this is for eyes training. You can see this rule. In my cron tab file.
We don't see anything. Ну, лучше он туда посмотрите, на экране
Так. Every 10 minutes pause for 5 seconds to relax eyes, and every hour pause for 4 or 5. Every hour pause for 4 or 5 minutes to relax body. Go playing table tennis, for example.
Workout, your workout, yeah. Workout. Ну, неплохо, приглашай.
Okay, so chain contains chain is list of contains list of rules. Each rule has criteria, action, and counter. You may define user chains, and let's see the way of packet in netfilter. Packet that came from and chains with common functionality are taken into a single table. Example, here we see this chain is in table row, in table mangle, in table nut. Chain forward is in table mangle and in table filter. And notice that chains with the same name, but in other tables are different entities. So this forward chain and this forward chain are different chains. They have a common name, but they belong to different tables. Okay. The tables are row table. It is used to handle packets before they are passed the connection tracking, the state machine, the part of firewall that determines does this packet belong to some new connection or it belongs to some existing connection. Row table may be used if you don't want packet to go those state machine. You may mark it special so it doesn't go those state machine. And also, yes.
To get in.
Сначала это спросите who is it,
Don't let them
когда
in.
будет цикл.
Oh, hello.
And here I see student.
Cranial.
Yeah.
Okay, I should draw him.
У вас двое одинаковых.
Okay. And also you may use row table if your server is under distributed denial of service attack. If you ban attackers' IP addresses in row table, your server will not use additional resources to handle this packet, because when packet passes the connection tracking machine, server uses some resources to handle it. So, Mongo chain. It contains default pre-routing table, forward table, post-routing table, and almost everywhere. Almost every default, almost every chain contains in Mongo table, is contained in Mongo table. So it is used for modification of packet. For example, you may change TTL, you may change type of service, you may mark packet. For example, this mark can be used by traffic shaper. So, NAT table is used for network packets translation. It contains pre-routing and post-routing chains. I will tell you about network address translation later. And filter table, it's stable by default. For example, if you say here we see filter table, it is default table if you didn't say, for example, T-NAT. So, in forward table, we can see chains input, forward. In filter table, we can see chains input, forward, output. And here they are. Forward, input, output. Filter table is used for filtering traffic. Okay, now we see tables, and now let's look at standard. Yes. Traffic is filtered by rules. Rule. Okay. Here it is. Rule can contain several criteria: IP address, protocol, destination port, some fields of used protocol. There are many criteria, and IP address is one of them. So, pre-routing table is used for packets Prerouting chain. Prerouting chain is used for packets that came from network, and this chain in every table is applied before a routing decision. When we got some packets from network, we should decide, is this packet for our local process, should we pass it to some local application, or should we try to forward this packet to another host? So rules in pre-routing chain are applied before routing decision. Then for packets that are for our local applications, rules in input chain are applied. Input to our host. For packets that in routing decision we decided to forward to some other host, the forward chain is applied. Then second routing decision, because in forward chain we may change some properties of packet, so it should be rerouted. For packets that came from local process, output chain is used, and again we have routing decision before output chain, and we have routing decision after output chain, because we may change some fields in packet. And post-routing chain, it is used to handle all packets that are finally handle all packets that are going to network after routing decision. Let's see an example how this works. Here host C is router, host A and B are just simple hosts, as you see on this scheme. So, and you see we may ping host A from host B. Packets are going through host C. Here is simple Iptables file. The first, it cleans all chains and all tables, and it deletes all user-defined chains. So every time we run this file, we run this script, all chains, all rules are created first time. Here you see default policy. The user-defined chains doesn't have default policy, but system chains, forward, input, output, do have a default policy. Default policy is rule that will apply to every packet that passed through all our chain but didn't match any other rule. So here we see for forward table we apply default rule drop, and for forward table, for packets with established and related state, we use rule accept. So if some connection is permitted, if some connection is accepted by our firewall, then connection tracking machine will handle it. We can see that it is related to some established connection, and we can accept it, we can pass it in the first rule. Okay. Let us apply this script. let us see. Chain forward, policy drop. Okay. Now we cannot ping host A from host B because here on router this traffic is prohibited. But you see that in input chain, in table filter, the default table, the same output because filter is default table. In input chain we accept all connections from our loopback interface because loopback interface is often used by some programs. It's necessary for them to work. And we accept in third rule all ECMP packets. So we cannot ping host A, but I have made some mistake here. Yes, I made some mistake. Now I should fix this mistake. Okay, so with clean Iptables, everything is okay. Так, input. Oh, everything is fine. I am accepting its MP packets just with type fragmentation needed. So, let us accept every ECMP packet. We can ping the router, but we still cannot ping our host A. We can ping router because these packets are accepted in input chain, packets for our local process are filtered in an input chain and we accept them. But packets for other hosts are filtered in forward chain and we do not accept them, we drop them. Okay, let's change the rules. Let's add to forward chain in filter table the default table, the rule that accepts ECMP packets. Now we can ping the other host A, and notice that when we ping some host, The first packet is going from host B to host A, and then the repeat packet is going from host A to host B. We have no rule in our forward tables, forward chain for any packets. Here we have this rule, but the answer packets will be accepted in the first rule as related established packets, because the answer packet is hello, and here I see student. Here I see some anonymous student. Am I right?
Шоу-шоп.
Okay. So the answer packet from host A to host B SMP echo reply is accepted in first rule of forward chain. And let us change the rule so that source then no. Let us accept it's our network mask. Maybe I am not right. Let's check. No, I'm right. Our mask is 24. So source only from this network. Okay. Now we still can ping host A, but host A cannot ping us. Why this is so? Okay, packets from host B to host A they are tracked by the second rule in forward chain. We are forwarding all SMP packets from TENS network. Answer packet is handled by first rule. We accept all packets that are related to some already established connection. Connection tracking machine helps us to understand that these packets is answer packets. It's related to already established connection. But packets from host A to host B are not handled by this rule. They doesn't match any of these rules. So it is handled by default policy, and our default policy in forward chain is drop. Okay, you can see here 4 packets transmitted, and you can see in forward chain counter 4 packets.
А я не понял, почему обратный пакет не подходит.
Okay, one more time.
Потому что source мы указали типа 10.00.
Packets with source from TENS network are handled by second rule in forward chain. We accept, we are forwarding every SMP packet from TENS network. Then the answer packet from host A to host B is also going the forward chain. But we have no explicit rule for this packet. We don't have rule for packets from 182 chain to 10th chain. But we have the first rule for packets related to some established connection. So connection tracking machine, here it is, it defines that this packet is related to some already established connection, to our SMP ping that we already accepted. And so answer packet from host A to host B is handled by first rule in forward chain. But when we try to ping host B from host A, when the first packet is going this way, then it doesn't match first rule because connection is still not established. It doesn't match second rule because it is not SMP packet from 10th network. So it is handled by default rule. Default rule, you can see chain forward policy drop. Default rule is drop. So we drop this packet, and host B doesn't see this packet. Packet is dropped on host C in forward chain. Understand?
А можно еще
А-
chain forward, он действует только когда мы пересылаем из одной сети в другую?
Yes, chain forward is used for packets that went from some network, somewhere from network, from some other interface, and we decided to try to route it to other host. Here is routing decision. If we decided that packet that came to our network interface is for our local process, then it will go through the input chain.
А local это какой? У нас он есть? У нас будет host C, да, он local C.
Local, every process running on our machine is local process. Any more questions?
Where is there drop the lock detail at
Uh, you better speak with Russian emphasis.
Там IP-таблица, где находится ключевой словарь именно того, который делает дроп пакета. Или это по умолчанию свойство?
No, this is not done by default. In my script, I added P Iptables P forward drop policy drop. Policy is default rule.
А я не вижу где-то строчку.
At the top.
А, вот, все, выше.
Here it is. Any more questions? Okay.
А вы сегодняшнюю лекцию не записываете, да? Записываете? Ну ладно.
So, how much time do we have?
10 minutes.
We have till 10 minutes.
Отлично английский.
Um,
Как это? Роман, прекрасно. Какое слово? Хорошо. Блин.
Okay.
Какое вы слово говорите? Russian, что-то там
emphasis, in Russian accent.
Russian accent?
Strong Russian accent.
Это не Russian акцент, это когда сербский говорит.
No, I won't speak from my heart like Mr. Mutko.
Speak from my heart.
Okay, let's see what packet state can our connection tracking machine can give to us. The state new is a packet that opens new connection. For example, if we ping some host, the first packet is handled as new packet. Established is packet that is part of already opened connection. For example, the SMP echo reply packet is established. It has established state. The related state, it's very interesting. It is for packets that opens new session related to some running session. This is for some protocols like FTP, which can establish several connections in active FTP. The first client connects to server, and second server connects to client. So to accept second connection, and these are two different TCP sessions. So to accept the second connection from server to client, we need the related state. Untracked state are packets that before connection tracking in row table we marked as untracked. So these packets will not be tracked by connection tracking machine. And invalid are packets with some improper set fields. For example, TCP packet with ask field establishing new connection, and the same time with the fin field that finishes the connection. This packet is invalid, it's improper. Okay. Here you can see some examples. Let's do something interesting. Okay. Let us add to the forward chain some other rule. State new. Okay, now we added the rule to forward chain the third rule for new packets. For packets that are establishing some connection. Так, host B, host A. Так. And now we can ping host B from host A. We still have policy drop in forward chain, but packet from host A to host B is new packet. It creates new connection. Yes, and in Iptables terminology, connection the world connection is used more widely than in. It's not about just TCP or UDP session. For example, if we ping some host, connection tracking machine in Iptables is thinking that this is connection. But actually, this is not a connection like in TCP. So packet from host A to host B is a new packet. It's packet for new connection. So it is accepted by third rule in this chain. And the answer packet is accepted by first rule in this chain, because it is a packet from some already established connection. Any questions? Yes, I'm configuring firewall on host C. On host B and A, firewalls are unconfigured. We may configure them. For example, policy drop for input chain. And our ping doesn't work because the ping packet from host A passed the host C but was rejected on host B. Okay, how much time do we have? After a boot, all settings configured with Iptables utility will be lost. Not lose these settings, you may configure some script like Iptables as such, and you can, for example, add this script somewhere to etc network ifupd. So every time when some interface is brought up, Iptables are configured. And you may also do this. So post up root. So when the interface ETH0 is brought up, our script will run. Let's check if this works. Okay, it works. So when our interface was brought up, our script was ran, and here are our rules. On practice lesson, you will try to filter some traffic forwarding from one host to another. Our lecture is finished. Я наконец